Hey, hi, my friend. Good evening and warm welcome to Cat Mojos. That's how we are branding this particular series, Cat Mojos for Cat 22 as well as for Cat 23, and especially with respect to Cat 22, we could say. And yes, so we are starting this particular course with the foundation, then intermediate, and then advanced. Right. So we'll start with the foundation. Might take about a month and a half because from the quant foundation perspective, we might have to look the foundation from the background of all areas of quantitative aptitude, majorly classifying it as arithmetic, algebra, numbers, and geometry. Right. That's how we kind of classify it. So we will look at the foundation part of it. What we do in the foundation part of it is we will try and recall some of the concepts that we did from from the high school, maybe sometimes from the college, some certain portions of algebra, or I didn't do maths in 11th and 12th. Certainly the foundation will help you to gear up for the CAT algebra technically, because a part of that algebra is come from the 11th and 12th standard as well. So technical phasing, so we do this entire study in about 3 phases. One is the foundation phase, the other one is the intermediate phase, then we'll do it in the advanced. Right, the foundation phase might not take more time. It should be somewhere taking about 1.5 months maybe, and then intermediate stage might take a little more time, might take about half months it could be. Advanced stage again might take somewhere about 2 months kind of. Advanced will have a lot of revisions as well, right? So this is how we kind of park our QA preparation of quant. Similarly, when I come to the DI and LR, I will also tell you the timelines as to how we are technically looking at this. So sure, after all this, we'll have a reinforcement phase, right? Reinforcement, that is revision phase. So that we will do it much closer to the CAT as well. So that's how technically the structure would look like. So all in all, you would say that, hey, it is technically about a 6 months course. Right, if you are technically looking at this, it might take about 6 months to reach that particular level of expertise that we are kind of looking at. And yes, reinforce, we will take the rest of the time to rest of the time kind of like to understand and how can I maximize my score. It's more of the testing phase, the reinforcement from there, and there are multiple ways to reinforce, which we will talk about it maybe after 6 months from now. So that's how we kind of look at this particular course, right? Yeah. Before I get into the course, let me quickly introduce myself. I'm Belvi Srinivas. I've been working in the test prep industry for the last 14-15 years now. That's since 2007. I worked in various organizations under various capacities, both on the management side of it, also on the training side of it. So as you can see on this particular deck, you understand the organizations that I kind of worked with in different capacities. And yes, I'm also involved in student counseling, helping them to make the proper study plans and then execute them and make the proper test plans and etc. So that's what we mean by counseling, taking them from point X to point Y and helping them to get into the top B schools, right? So that's technically that's my expert area. How do you reach out to me? You can reach out to me using one of these Telegram channels. So you can, if you have any short concerns, very objective questions or that you would like to ask, or you want to get some doubts resolved, this can be a channel through which you can kind of interact with me. Yeah, that's quickly about the background. Just in case if anybody here from CAT 22 perspective, CAT 21 perspective, here is the marks for you, because this course is primarily for CAT 22 and CAT 23. Just in case if you are preparing for ZAT, somebody here from a CAT 21 student appearing for ZAT as well. So here are 2 mocks that you can consider taking. Here is last 1 mock, that's on 26th, this particular Sunday. Come next Sunday, the first Sunday of the new year, you would be appearing for that. I'm sure along with this particular mock, you might have planned some of the other mocks as well in between the week, right? Yeah. So this is the comprehensive mock that you can consider taking it. And yes, there is a combat as well, Unacademy combat for decision making, technically for decision making. Yes, you can consider this. So there are certain vouchers. This test is on 25th of December. That's on the Christmas day. That's on Saturday at 12 in the afternoon, and it's a 60 minutes test with 21 questions on the similar lines of ZAT decision making. And if you happen to do really good on it, then you would be winning some of the Amazon gift vouchers, maybe up to rupees 10,000. Right, you can use my educator code to also participate in this particular quiz. Yeah, that is from those who are appearing for ZAT. Not appearing for ZAT, this course is meant for the people those who are appearing for CAT and ZAT in the subsequent year, not in this coming cycle. Fair enough. So that brings us to the kind of the lecture here. So what we do here is basically, if you look at the numbers, I started with the numbers module. Maybe I will continue this particular module in about 7 odd lectures or 8 odd lectures. And then we will shift to a little bit of algebra. Then we will shift to the arithmetic. Likewise, we will do the foundation for about the next 1.5 months. We will lay the foundation for the quantitative aptitude. What we do on this front is we will be doing divisibility and its applications. So that's what I'm starting today. Then we'll get into the LCM HCF. It's not about teaching LCM HCF, don't confuse me here. It's not about the teaching perspective. It is more to do with, hey, what are the applications, what are the simple things we should remember from the high school before we deep dive into the intermediate level, which is kind of at the CAT level, or advanced level, where some of the difficult questions in the CAT are kind of asked. Right? And then we'll also look at some of the factors. Of course, all these things come from the class 4 onwards. Divisibility, LCM, HCF, factors, all these are class 4 questions we're talking about. But yeah, but we don't talk at the class 4 level. Class 4 to class 10, you came across these concepts. Let's try and see what is the quick review or recap of these particular concepts. Yeah. So this is the set agenda. So what we do is we will start off with the divisibility. Those who are here active, a little bit active in the lecture, can we exchange the greetings? Who are here? Eric, I can see here. Hi Eric, glad to be here. Good evening Eric. Yeah. Are we good to start? The audio, video, visuals, everything should be fine. I think so. We are good to start out here. Right? Yeah. Okay, so when it comes to the divisibility, when I'm talking about the divisibility perspective here, your teachers might have said, hey, divisibility, the basic fundamental rules of divisibility come from prime raised to power n series, right? That is one series. The rules come from prime raised to power n series. What do you mean by prime raised to power n series? It can be 2 raised to power n. It could be 3 raised to power n. So I'm saying, what is this prime raised to power n I'm talking about? 2 raised to power n series, 3 raised to power n series, or it could be 5 raised to power n series, it could be 7 raised to power n series, 11 raised to power n series, 13 raised to power n series. Now this is the fundamental to start with, right? The fundamental part comes from powers of 2s, powers of 3s. Why these 2, 3, 5, 7, 11? Why am I not talking about 6 raised to power n or 8 raised to power n? I'm not talking about the composite number series. The first part always comes from the prime raised to power n series, right? Yeah. So what we learn, let's see what all we have learned in the high school, where we would have stopped, and from CAT perspective, what else we need to focus upon. Let's try and take a look at this, and let's at least learn and revise from the high school perspective to start with, right? Yeah. Let's take a look at 2 raised to power n. So what is this 2 raised to power n series we are talking about? Divisibility rule for 2 power 1, because n can be 1. Divisibility rule for 2 power 2. Divisibility rule for 2 power 3. Divisibility rule for 2 power 4. Divisibility rule for 2 power 5, etc. We can go on. From the CAT perspective, this is the stopping point, right? And of course, we have done all this in the high school as well. 16. So what is this? It's a divisibility rule for 2, divisibility rule for 4, divisibility rule for 8, divisibility rule for 16, divisibility rule for 32. We know that if there is a large number, maybe a 20-digit number, a 30-digit number, it doesn't matter to me how large is that particular number. Yeah, in the exam, sometimes it will be a 100-digit number as well. But when I ask a divisibility rule for 2, all I got to do is, hey, I just have to look at the last digit to tell the remainder. For example, there is a number 1, 2, 3, 4, and went on and on and on. Finally, it is looking like 239, right? Now, this is where the last digits are looking. There are so many digits in between. Assume that it is some 1000-digit number, but the last 3 digits looks like 239. Simple. Hey, when this number is divided by 2, what is the remainder? All I got to do is, hey, divide the unit digit by 2, figure out what is the remainder. Here, the remainder is nothing but 1. So that is it. In the sense, the remainder also can be said by knowing the divisibility rule. Divisibility rule is not only tells that whether the number is divisible or not, it also tells that what is the remainder, what is the reason it is not divisible. How do I look at the divisibility rule for 2? I just look at the last digit of the number. Similarly, what is the divisibility rule for 4? I just have to focus on last 2 digits of the number. Assume that this is a 1000-digit number. What I wrote here is a 1000-digit number. I just projected the last 3 digits, let's say. Okay, what is this number? When is this number divisible by 4? Answer, we all know that it is not divisible by 4. Surely, but then what is the remainder? What is the reason it is not divisible by 4? I will divide this by 4 and I will say that the remainder is 3. It doesn't matter what were the other digits. I just focus on the last two digits, which is 39. I divide by 4, 36 is divisible, and hence the remainder is going to be 3. Likewise, 2 raised to power 3. I look at the power 8 means 2 raised to power 3. I just have to focus upon last 3 digits of this particular number. For example, if I'm looking at this number, I will simply divide this by 8 here, and I will say that, hey, this remainder is nothing but 7. Okay, how do you say that? You say that, okay, 2 times 16, 2 times 16, and then, okay, you are doing this division technically, nothing else, right? So 8 2 times 16, therefore you have 79. 8 9 times 72, therefore 7 is the remainder. And then simply say that this 1000 digit number when divided by 8, 7 is the remainder. Likewise, from the CAT perspective, till where I should know till the divisibility rule for 13. Okay, even beyond that, it's of course not a problem, but from the CAT perspective, you know that, okay, last 3 digits, last 4 digits, and last 5 digits, right? This is what it is. Now, this rule is precisely same. This rule is precisely same for 5s as well. I finished the 2 series now. So it can go on and on and on, but doesn't matter. I would stop at 2 raised to power n. So yeah, I will take the problems. Once I quickly illustrate from the CAT perspective how much I should know from here, right? Yeah. So this rule is precisely same for the powers of 5 as well. A 5 power 1. So what is the divisibility rule for a 5 power 1? Last digit. What is the divisibility rule for 5 square, which is nothing but 25? Simply the last 2 digits. I just have to consider the last 2 digits. Hey, what is the divisibility rule for 5 cube, which is nothing but 125? Nothing but simply look at the last 3 digits. Hey, what is the divisibility rule for 5 raised to power 4? That is 625. Okay, from the CAT perspective, till here I should know. I'm not saying that beyond this it may not come. It has not come. That's it. It has not come. It's up to 625, which is fashionable in CAT. 625 is one of the typical numbers being used in CAT. And hence I'm saying that from the CAT perspective, up to 5 power 4 I should know. The fundamental divisibility rules come from the concept of p power n. This is what is taught in the schools. First, I'm quickly revising it as the part of the foundation here, right? Yeah. So therefore, that's about the 5 power n series. For example, okay, if I go back to the same question, for example, if I say that, hey, is this number divisible by 5? We know it is not divisible by 5. How? Just take a look at the last digit. Divide by 5. What is the remainder? 4. Every divisibility rule tells you the remainder as well. Remainder is nothing but the reason why it is not divisible by 5. The reason it is not divisible by 5 is there is 4 x's in this particular number. So that's a point there. Okay, is this number divisible by 25? Of course not, because 25 we know tables of 25, 25, 50, 75, etc. right? Then therefore you look at this. Then what is the reason, which means what is the remainder? Just take a look at the last 2 digits, 39. 39, you divide this by 25, you understand that the remainder is nothing but 14. All right, that's what you are trying to say out there. Similarly, is this number divisible by 125? What is the divisibility rule for 125? Last 3 digits. So therefore you say that you divide this particular number by 125, and you say that, hey, the remainder therefore is nothing but 114. All right, that's a remainder on this particular number. 114 is the remainder. Simple. So we know the reason. Every divisibility rule tells you the reason in case if it is not divisible. Okay, I finished 2 series. Then coming to the 3 series. Of course, you guys would have learned this 3 series. So 3 raised to power n, which means what? 3 power 1. There is a 3 power 2, right? There is a 3 power 3. From CAT perspective, these are the 3 numbers which are important. Means divisibility rule for 3 is important, divisibility rule for 9 is important, divisibility rule for 27 is important. You may say that divisibility rule for 34 is 81. What about that? It has not come so far in CAT, right? So far it has not come. I don't think it is very unlikely to come. So let's at least focus on what we know from high school and what is the thing right now that we need to know from CAT perspective as well. Okay, can some of you type it in the chat? What is the divisibility rule for 3? What is the divisibility rule for 3? Can you guys move your fingers a little bit in the chat and let me know what is the divisibility rule for 3? If I give you a 10-digit number, how do you understand that is this number divisible by 3? How do we go about understanding this? Can you guys put it in the chat, please? Yeah, one of you, one of you type it in the chat. What is the divisibility rule for 3? That's my question to you. No idea? That's right. Shruti says that sum of the numbers. Asim says that sum of the digits should be divisible by 3. Amazing. Very good. Very good. That's right. That's right. Okay. Yeah. So that's right. Sum of the digits of the number. Basically sum. Sum of the digits. Right. Very good. Very good. So you are technically talking about the sum of digits. Right. Sum of digits. Same goes with 9 as well. It is also sum of digits. Sum of digits. Okay, now 27 I will speak about this at a later stage, right? In the intermediate stage I will talk about this. Now it's too early to speak about this 27. I will speak about 27 at the intermediate stage. Now from the school perspective, this is not sum of digits. You may be wondering, okay, this is also sum of digits, right? You may think that, if you think that, hey, this is also sum of digits, no my friend, this is not sum of digits, because had it been sum of digits, your teachers would have been already taught about it, right? Yeah, so because they stopped at 9, reason being, for 3 power 1 and 3 power 2 it is sum of digits. For 3 power 3, which is 27, is the number divisible by 27, it is not sum of digits, right? It is not sum of digits. Then what is it? We will come to it at an intermediate stage. Right now it may not be required, just like a gym, right? There is no hurry. You just entered into a gym, let's say, that you don't have to really hurry and try to lift the dumbbell from one hand, which is about 16 kgs or 20 kgs. You don't have to do that, right? So you may break your you may break your back if you try to do that. Start with 5 kgs or start with 2 kgs, start with 7.5 kgs, whatever is the appropriate weight. Oh sure, you will definitely reach that stage of lifting 16 kg dumbbell very soon, right? That's what the decision I'm taking. I don't want to break you down. So we know that, hey, 3 power 1 in the foundation, we will first understand that at the high school level, whatever I learned is very clear to me, crystal clear to me. From there, let's move on as to how do I proceed to the intermediate level. Okay, now 3 power 3, but from I'm setting up that expectation that where I should stop this series. You should stop this series technically at 3 power 3, which is 27. That's where you need to stop. But what we know today is 3 power 1 and 3 power 2. For example, if I have this particular number 1, 2, 3, 4, 5, 6, hey, is this number divisible by 9? So I just add the numbers 3, 6, 10, 15, 21. Sum of the digits is 21. Again, add the digits. What is 2 plus 1? 3. 3 is the remainder, which means when you divide this 1, 2, 3, 4, 5, 6, this 6-digit number by 9, you get 3 as the remainder. Right, now keep adding until it becomes a single digit number, right? And that single digit number, if it is not divisible by 9, then that itself is going to be the remainder. This particular six digit number is not divisible by 9 because it has 3 extra in that. Remainder is nothing but the excess portion of it. You subtract 3 in this number, it would automatically become divisible by 9. Fair enough. Okay, now that sets up for the 3 raised to power 9, 3 raised to power 9 as well. Now coming to the later issues. Right? So 7, I don't think most of the schools might have taught that particular technique. Most of the schools do not teach 7. I'm here. So, but from the CAT perspective, only 7 power 1 is important. Only 7 power 1. You don't have to know what is the divisibility rule for 7 square, but divisibility rule for 7 power 1 is important. Again, we will take it up at the intermediate level. We will park it for the intermediate level, right? Yeah, 11 power 1. From the CAT perspective also, only 11 power 1 is important. 11 power 2 is not important. Only 11 power 1. I'm sure 11 power 1, everybody kind of remember because it's one of the popular concepts taught in the primary school or high school, somewhere about 7th standard, 8th standard, somewhere around that time, right? That's when you learn the divisibility rule for 11, right? So let me quickly illustrate that. Anybody wants to put it in the chat? What is the divisibility rule for 11? If you quickly want to put it in the chat in your own words, you can put it quickly in the chat. I will wait for a few seconds. If you quickly want to put that in the chat, what is the divisibility rule for 11? What you remember from your high school? You can plug it in the chat quickly. Go ahead. Anybody would like to? Hey, we have to go to the problems as well quickly. You remember something in your own words, doesn't matter as long as I understand. Even if you just put it, don't worry about the words being in the order, not in the order, as long as I understand, it's fine. Anyone? No one? All right, Asim, you don't remember. Good. Yeah. That's a nice response, right? Yeah, if somebody is responding, that is always good. Please think about it. Yeah, that's good because I don't see you guys. It's a very nice. All right, now even if you don't remember, you can always say that, yeah, I don't remember, kind of. That's good always. Yeah. All right, yeah. So let me put it to the perspective, right? 11 is sum of the digits of difference between the sum of the alternate digits. Let me repeat this. Difference between the sum of the alternate digits should be divisible by 11. However, if there is an order to it, let me put that to perspective. Say there is a number 2, 3, 5, 7, 2. Let's assume that. All right, let's or 6 to start with. Let's put it like this. So sum of the digits starting from the units place. Your teachers would have said that, hey, first sum of the alternate digits starting from the units place. Sum means add. So these numbers I need to add. What is that? 6 plus 5, which is 11. 11 plus 2, which is nothing but 13. Okay, so this is nothing but 13. Similarly, sum of the alternate digits starting from the tens place. There is an order to it. I can't do whatever I feel like doing it. There is an order to it, and I have to follow that protocol, right? That's very important there. Sum of the alternate digits starting from the tens place. Therefore, 7 plus 3, you call it as 10. Right, 7 plus 3, you call it as 10. Now you must do u minus t only. Whatever you feel like doing, it must be u minus t, right? So u minus t, that's the sum of the alternate digits starting from the units place minus sum of the alternate digits starting from the tens place is nothing but 3. In fact, when you divide this number by 11, 3 is the remainder. Instead of it becoming 3, what if, now this difference, instead of becoming 3, what if it would have been 0, or what if it would have been 11? 11 can be plus or minus 11 also, plus or minus 11, or plus or minus 22. Then you say that, hey, all these numbers are divisible by 11. Therefore, the given number will also be divisible by 11. Therefore, the given number will be divisible by 11. That's a point here we are talking about, right? Okay. So that's the thing, like, which means the difference between the sum of the alternate digits is what we are kind of trying to look at. Okay, so let's keep it to the perspective. Now in this case, what if I change this particular number? Think about this. This is very important. I want you to be mindful about this. Say, let me take this number 2, 3, 5, 7, 1. I wrote something like this. Then sum of the alternate digits starting from the units place, right? Sum of the alternate digits starting from the units place is nothing but 8. Sum of the alternate digits starting from the units place is 8. Sum of the alternate digits starting from the tens place, all right, that's nothing but 10. Now when you do u minus t, you will get minus 2, which means there is a deficit of minus 2. What is the meaning of this deficit of minus 2? What is the actual remainder? You have to add the divisor. In case if the negative, this is actually a remainder. Minus 2 is a remainder. If the remainder becomes negative, you got to add the divisor. When you add divisor, it becomes 9. 9 becomes the remainder. Technically, which means in this 5-digit number, there is 9 extra, because of which it is not getting divisible by 11. Therefore, it is not simply difference. So if you say difference, then it will become 2. What is this 2 means? If you say some people remember that simply the difference between the alternate digit. If you remember it as a difference between alternate digit, it is quite likely that you may end up getting the number as 2. Alright, you may end up getting the number as 2, but this 2 does not mean anything to us. It is neither a remainder, nothing, right? Technically, the remainder is 9, and hence you got to remember divisibility rule for 11, as your teachers told in the high school. You got to remember that, hey, it is always sum of the alternate digits starting from the units place minus sum of the alternate digits starting from the tens place. When you do that minus, it can become a negative number as well. If it becomes a negative number, and which is not minus 11, in that case, add the divisor to get your remainder, because every divisibility rule tells you the remainder also. Making some sense? Asim, clear? Others as well, whoever wants to respond. Please, Asim looks quite active. In the chat, you may be actively listening, but from the chat perspective, he's kind of little active. Yeah, I hope it made some sense, because you said that you don't remember the 11. Yeah, I guess now you are able to recall and remember the 11, right? Okay, all right. From the cat perspective, 13 raised to power 1 is important. That is 13 is important, but I will park it for that intermediate level. So now I'm parking 3 important divisibility rules for the intermediate level. Along with that, many other things I'm going to discuss. Say, what is that? All right, I'm parking it aside. I'm parking it aside. Divisibility rule for 27, divisibility rule for 7, and divisibility rule for 13, which we will look at intermediate level of our discussion. Because what we are doing at the foundation level is we are trying to ensure that whatever we did in the high school, we are trying to consolidate that learning well. All right, that's what we are trying to do out here. Yeah, so let's this is one portion of the study that you guys might have done in the part of the high school. Then you come to the second stage. What is the second stage? Second stage is, this is the stage one that you learn. All right, this is the stage one. Stage one is what? All the rules for the numbers of the form prime raised to power n. This is the stage one, prime raised to power n, that is 2 power 1, 2 power 2, 2 power 3, just like I said. Second stage is the numbers made up of the number, divisibility rule for a number. You are a divisor, in the sense your divisor is made up of two different primes, prime raised to power a and prime raised to power b. Which are those kind of numbers? For example, 6, classic number is 6. 6 is nothing but a 2 raised to power 1 and a 3 raised to power 1. So this is what 6 is. So it is not made up of one single prime unlike other numbers. This is made up of two different primes, that is 2 raised to power 1 and 3 raised to power 1. So when you put it to the perspective, what does it mean to us? Simple. Hey, where did I already learn 2 raised to power 1? Yes, that is the last digit. Did I learn for the 3 raised to power 1? Yeah. Yes, because that's the sum of the digits. I already learned these two premises and it should be true for both of them. In the sense, if I take a number, say for example, the number is 1, 2, 3, 4. Let's say this number. Is this number divisible by 6? Question is this number divisible by 2? Yes, right? Because 6 is made up of 2 power 1 and 3 power 1. Is this number divisible by 2? Yes. Is this number divisible by 3? Sum of the digits of the number 10. 10 means the remainder 1. So no. Since this number is divisible by 2 but not by 3, this number 1, 2, 3, 4 is not divisible by 6. It's not. It is not divisible by 6. On the other hand, let me take another number. Hey, what if the number is 1, 2, 3, 4, 5, 6? Let's say that this is the number that I wrote. Fair enough. Now the question is this number divisible by 2? I look at the last digit. I say that yes. Is this number divisible by 3? Sum of the digits of the number is 21. Therefore, you say that this is also divisible by 3. Since this number is divisible by both 2 as well as 3, I say that this number is divisible by 6 also. This is how you do. So therefore, now let me quickly ask you another question. What is the divisibility rule for 12 then? Divisibility rule for 12 means you take this 12, start dividing by primes, 2 6 times, then 2 3 times, stop when you get a prime number, and then you say that 12 is nothing but a 2 and a 2, that is 2 square, and a 3 raised to power 1. Divisibility rule for 12 is unique. My point is divisibility rule for 12 on earth is unique, everybody, in the sense, hey, it is the number should be divisible by 4 as well as 3. There is no matter. The number should be divisible by 4 as well as 3. For example, if I ask you this particular question, hey, is this number divisible by 12? This number 1, 2, 3, 4, 5, 6, is this number divisible by 12? Simple. I look at the last two digits, say why last two digits, man? That's a divisibility rule for 4. 2 power 2 means divisibility rule for 4. Is 56 divisible by 12? Answer yes. Is this 1, 2, 3, 4, 5, 6, sum of the digits 21? Is this divisible by 3? Answer is yes. Therefore, is this number divisible by 12? Answer is yes. Since it is divisible by both 4 and 3, the number is divisible by 12 as well. So now let's go. Let me ask you a randomly some question. What is the divisibility rule for 18? Simple. You got to revise, you got to write it as 2 power 1 and 3 square. Do you know the divisibility rule for 2 power 1? Yes, from your earlier experience you already know. Do you know the divisibility rule for 3 square? Yes, from your earlier experience you already kind of know. Therefore, the number is divisible by 8, and for the number to be divisible by 18, it should be divisible by 2 as well as 9. Let me ask you a question. Okay, what is the divisibility rule for 72? I have a 10-digit number. How on earth I understand that is this number divisible by 72? Can you tell me it should be divisible by which two numbers? Why don't you guys put it in the chat? For the number to be divisible by 72, it should be divisible by which two numbers? Yeah, take a few seconds and let me know how do you go about this. Okay, after some time you will get them in your mind itself. No, not like that, Asim. After some time you will get these numbers in your mind itself. All you do is you take 72, start dividing the prime 236 times, start dividing by prime till the time you end up with another prime, right? 36 is not a prime number. So therefore again you take another 2 and you say that 218 times, take another prime 2 9 times, 3 times, are you prime, you stop it. Now you understand that hey, it is 2 2 and 2, that is nothing but 2 cube, And then you will say that there is a 3 and a 3, therefore it should be divisible by 3 square. It should be divisible by 8 as well as 9. If the number is divisible by 8 as well as 9, then the number will be divisible by 72. What you got to do is you got to take that number and present it as the primes like this. Alright, your divisor should be presented as prime raised to power something, and then you have to interpret that whole number as it is. What is 2 cube? 2 cube is nothing but 8. You should take completely like that, not just 2, because technically 8 into 9 should be giving back the 72. It should be divisible by 8, for which you know the divisibility rule. It should be divisible by 9, for which you also know the divisibility rule. It should be divisible by both these numbers so that the number will be divisible by 72. Clear, Asim? Did it make sense? You understood? You understood? Clear about this, what I'm talking? Yeah. Others, whoever is in the meeting, is it making sense what we are discussing? Any doubts? Yeah, cool. That's good. All right. All right, fine. Let's go to some of the applications. Now, having understood this, let's go to some of the applications which kind of exam questions also, right? These questions are kind of exam questions as well. Try and do with me. All right, try and do with me. I will do a couple of questions, maybe from the third question onwards. Probably I will give you some 30 seconds of time for you to think. For the time being, do these questions along with me. Okay, what does it say? Given that there is a number, right? Now it's a 10 digit number, 1 2 3 4 5 6 7 8 9, and then last digit is k, where k is a digit, right? K is a digit. It is not multiple digit, it's a single digit. K is a digit, is divisible by 8. Author is saying that, look man, this particular number is divisible by 8. This 10 digit number is divisible by 8. Find the value of the digit k. Fair enough. So all I need to know is what is the divisibility rule for 8? Divisibility rule for 8 is last 3 digits. Therefore I will just take 8, 9 and k. That's it. I just take 8, 9 and k. I will start dividing this by 8. 8 one time 8, therefore 0, then I get 9, 8 1 time 8, therefore I get 1, and next I will get that k in front of this. Now I got to check from the table of 8 what number comes in 1 followed by something. I know that 8 2 times is 16, which becomes 0. Therefore I know that the value of k is nothing but 6, because author has given a guarantee saying that is divisible by 8. The given number is divisible by 8. That's what author is trying to give a guarantee. Therefore I know that this k has to be 6. The k has to be 6. There is no choice in the matter, and that's what he's saying. Find the value of k. K is nothing but 6. This is what we are trying to do there. But in the CAT problem, what happens is they will not use 8. Instead of 8, they might have used 16, they might have used 32, some larger numbers, better numbers. Technically CAT prefers to use 16 or 32 instead of 8, 4, etc, etc. If they are asking a direct question in SNAP or NMAT, there could be some direct questions, but naturally they would be preferring to use the numbers like 16 or 32. May not be 8, but yes, since we are just practicing and trying to recall the concepts, it's all right as long as we deal with the smaller numbers. I'm hoping that all of you know the tables till 20, right? Tables till 20. Knowing tables till 20 is very, very important to do the calculations. Despite CAT giving a calculator, no other exams generally give the calculator. IIFT no calculator, ZAT no calculator. No other exam has a calculator feature. So make sure that you kind of know the tables till 20, which is very essential. Fair enough. I hope this particular question has made some sense. I will go to the next one. On this note, let's move on to the next one. Given that there is another 6-digit number out here, we have a 6-digit number where k is a digit. Again, k is the unit digit. So is divisible by 9. Find the value k can take. We know the divisibility rule for 9. What is the divisibility rule for 9? Sum of the digits of the number. Let's add them up. Therefore 5 plus 3, which is 8, 8 plus 9, already 8 plus 9, which is 17, 17 plus 10, already which becomes 27. So which means 27 plus k. If you add sum of all the digits, it is becoming 27 plus k. So now I say that the number should be divisible by 9. 27 is already divisible by 9. Therefore you may say that the value of k can be 0. Value of k can be 0. Or I can say that, okay, in the sense 27 plus k should be equal to 27 case 1. Or you may say that second case 27 plus k is equal to 36. If from where you are writing this 27 and 36, you may ask that, sir, why you are writing 27 and 36? Because divisibility rule for 9 is sum of the digits should be divisible by by 9. I'm saying that 27 plus k can be equal to 27 itself, or you may say that no, it can be equal to 36 also. I agree, possible. Or you may say that no, 27 plus k is equal to 45 also. 27 plus k is equal to, already 27 plus k is nothing but 54 also. Yeah, possible. All these numbers are possible, but remember k is a single digit number. Keeping that in mind, 27 plus k is equal to 27, then k is equal to 0. Is it a single digit number? Yes, possible value. Okay, 27 plus k is 90, 36, therefore k should be 9. Is it possible? Possible. 27 plus k is equal to 45, which means k is 18. Is it possible value? No, because k is a single digit number. Not possible. Similarly, the next one is going to be 27. Not possible. Hereafter, it may not be possible. Therefore, he said that, hey, find the values k can take. Possible values. Can means what? Possibility. What are the possible values? K can be either 0 or 9. My point is, sometimes there need not be a single value. There can be multiple values that particular unknown, like a k or whatever. The unknown can take sometimes more than one single value. Okay, kind of. We did a kind of a warm up. Is it making sense? Clear here? Clear here? Yeah. Did it make sense? So far good. I quickly revised with some two simple questions. Divisibility rule for 8 and 9. Made some sense? Can someone quickly confirm in the chat that yes, it's making some sense what we are discussing? A little sense, yeah. Okay. Good. All right. So here comes a question, right? Now these are all exam questions. What I'm putting it here at the level 0, right? At the level 0 or level 1 kind of. What I want you to do is, when I present a question, yeah, thanks Rutish, thank you. Yeah, take a look at this particular question and think about it just for about a minute, 1 minute or 30 seconds, whatever. Just take about a minute or 30 seconds, just a reflection, just think about it. You don't have to necessarily solve in a minute because CAT is still 1 year away. You don't have to push yourself too hard, no worries, right? There is a time after 1.5 months, I will start pushing you very hard. For the time being, you could say that, okay, you can chill out a little bit, right? Yeah. So think about it. How do you go about this? Just think about it. All right, yeah, that's a good reflection time. Do it with me. Given that there is a 6-digit number here, because m and n are digits, which m and n digits means what? The values can be 0 to 9. Right, that's what you mean by a digit. M and n or digits is divisible by 9, right? Yeah, the digits are divisible by 9. Find the difference between the largest and the smallest value n can take, which means, as I told you in the previous example, there need not be one single value. There can be multiple values it can take. That's what we were discussing. So now let's think from that perspective. It's divisible by 9, given, guaranteed that it is divisible by 9. Therefore, what is the difference between the largest and the smallest value n can take, which means, hey, let me find what is the maximum value of this. Let me find what is the minimum value of this. The difference is what author is kind of expecting between these two particular numbers. Okay, so first, sum of the digits of the number. 7 plus 4, 11, 11 plus 8, 19, 19 plus 6, 25. Okay, you are trying to say that 25 plus m plus n. This is what we are saying. Alright, now this is what we are saying. Sum of the digits of the number is, I added the digits 4 plus 7 plus 8 plus 6, which becomes 25. M value I don't know, n value I don't know. If I say sum of the digits of the number, this is what it means to us. Very good. So now this should be equal to what? Minimum 27. Why minimum 27? Because I know that divisibility rule for 9. What number greater than 25 is divisible by 9? What number greater than 25 is divisible by 9? 27. That's a minimum value, right? 27. If not 27, what is the other value? 36. If not 36, what is the other value? 45. If not 45, what is the other value? 54. it goes on in your mind window. You don't have to write all of them. In your mind window, you are saying that the sum of the digits can be 27 or 36 or 45 and so on. So till where I should consider, that's a later issue. I have to just get what is the maximum value and minimum value. Fair enough. The maximum and minimum value. Now look at this n. I need to focus on n, right? Yeah, n can be 0, m can be 2. Therefore I got the minimum value. When I took this 27, you may say that no sir, why can't it be 1 and 1? Agreed, man. 1 and 1 is also possible. You may say that no sir, why can't it be 2 and 0? That is also possible. But I am trying to find out either minima or maxima. Let me find minima, because from here I can easily foresee the minima here. Logic, okay, I will take 0 here, I will put 2 here. So that is also fine. Therefore the minima is 0, because I know that the n can take a value between 0 and 9. So technically if I get a 0, nothing like it. Therefore now I got a 0. Alright, now let me try and get this 9 if it is possible. If it is possible, let me get this 9. From here it is not possible. Let me write another case. Alright, from here can I get it? 25 plus m plus n is equal to 36, because ballpark figure in my mind I know that n can take 9 also. That is the best value it can take, right? That is the best value it can take, right? Yeah. So therefore we say that hey, what is the value that I can take here? 9, right? Therefore I can give 9 here. Okay, yeah, so 9 here, and I will say that 29 plus this, and I can adjust this with 2 here. Sorry, 9 here and 2 here. Why? Because 25 plus 11, m plus n should be technically equal to 11. 25 plus 11 is equal to 36. If it is 11, how do I figure that out? 9 I will deliberately give here, and I will give it 2 here. M I will make it 2. That's how I will distribute this 11. So did I get my 9 as well? Yes. Maximum value is 9, minimum value is 0. Therefore what is the difference? The difference is going to be 9, because that's what the question is. Find the difference between the largest and the smallest value n can take. The largest value is 9, the smallest value is 0. Therefore the difference is going to be 9. Is it making sense? Everybody clear? Asim, clear? Clear? Did you get it? You can consider multiple cases to figure out your answer. You're getting this? Yeah. Okay, I think Shruti is clear on this. Nice. All right, so here we go. The other one. Yeah, think about it just for a minute. Think about it. You don't have to necessarily answer this, but think about this. Ah, okay, Asif, got it. Yeah, yeah. You can consider multiple cases. Okay, you can consider multiple cases. Not that you should take only one case. You can consider multiple cases as well. Yeah, go ahead, everybody. That's nice, Baba Dhule. That's nice name. Very good. Thanks for your response, guys. Go ahead. Just think about it. Think about it, right? Now, even if you don't answer in the given time, that's not a problem. But I don't want you to lose thinking abilities. Think about them. Now that we know kind of basics, just give a thought. Yeah. Okay, there is a 10-digit number, basically saying that how many ordered pairs, which means like x coordinate, y coordinate, there is the ordered pairs of A and B, the number will be divisible by both A as well as B. Ordered pair, which means one side A, one side B. For this value of A, there is a corresponding value of B, something like that. Okay, all right. It should be divisible by both 8 and 9. Sure, I will first start with 8. Why start with 8? Because for 8, I don't have to consider all the digits. That's an advantage for 8. Why should I consider all the digits to start with? Only 3 digits. Very good. I will consider only 3 digits. That's what the divisibility rule for 8. I will look at 9, 6 and B. Very good. 9, 6 and B. Let's divide this by 8. 8 1 time 8. Then you have 16. 8 2 times 16. 0. Then B comes as it is. Now you understand that B can take two values. Yeah, what are the two values it can take? B can be 0 itself, or B can be 8 also. B can be 0 or B can be 8. Two values B can take. You are trying to say that the B can take two values. Case 1, it can be 0 or it can be 8. Okay, let me take the case 1. Let me take the case 1 in which value of B is nothing but 0. After that I will come to the case 2 in which the value of B can be 8. Two values it can take because I reach the stage which is 0B. 0B should be divisible by 8. B can be 0 also, that is 960 is divisible by 8. 968 is also divisible by 8. Alright, you got the point. Either 960 is divisible by 8. 968 is also divisible by 8. Right, now these are the two values I got. So first case I am taking. In the first case the value of B is nothing but 0. Okay, if the value of B is 0, then how does my number look like? So number look like 5, 8, 7, 9, 4, 7. Then there is a A here. Then you have 9, 6 and 0. In place of B, I am directly writing 0 because in the first case, I took that particular number as 0. Add the figures here. Now you are checking divisibility rule for 9. What is this case when you are trying to do? You are checking whether this number is divisible by 9 or not. That's what you are trying to check. So let's see this. 8 plus 5, 13, 13 plus 7, 20, 29, right? 33, 40, 49, 55. All right, now you are trying 55 plus 0 is 55. You are trying to say that this has become 55 plus A. This number should be divisible by 9. Now you have to think 55 plus what will be divisible by 9. So it has to be minimum 63. It has to be minimum 63 because 54 is divisible, but you are already at 55. But there is a one variable called as A. Correct? 55 plus A should be next pit stop is what? 63. If not 63, what is the next one? 72. 55 plus A can be 72 also, and so on and so forth. Yeah, let's come to this. Therefore, what is the value of A? The value of A, therefore, in this case is nothing but 8. Alright, value of A is nothing but 8. 55 plus 8 is equal to 63. Alright, if I were to make it 72, then the value of A will be how much? It has to be 17. But A is a digit man. A cannot be 17. It cannot be a two-digit number. Therefore, this case does not work. Only one case works. In the sense what? Whenever the value of B is 0, you are trying to say that the value of A is nothing but 8. One ordered pair. That is 8, 0. When B is 0, the value of A is becoming 8. Okay, that concludes one case. Let me go to the second case. What I am supposed to be doing in the second case, I should be taking B value as 8. In the sense 5, 8, 7, 9, 4, 7, A, 9, 6, 8. This is what I should be doing, right? This is what I should be doing. So when I add this 8 also to this number, I add all these numbers, basically add all these particular digits. You understand that that will become 70, that would become 70, that would become 63. That would be 63 plus A. That is what it would become. All the digits are adding up to 63, but A is an unknown yet. This should be minimum equal to what? It can be equal to 63 itself, or what? It can be equal to 72, or what? It can be equal to 81, and so on. Good. So if 63 plus A is equal to 72, what is the corresponding value of A? 63 plus A is equal to 63. What is the corresponding value of A? 0. Second case, 63 plus A is equal to 72. What is the corresponding value of A? 9 possible. Third case, 63 plus A is equal to 81. Corresponding value is nothing but how much? 18. 18 is not possible. Therefore, you are saying that A can be either 0 or 9. Okay, so coming back to this, you are now trying to say when B is 8, A can be 0. When B is 8, A can be 9 as well. And hence how many pairs of values are possible? 3 ordered pairs are possible, which means put A is equal to 8, B is equal to 0, it works. Put A is equal to 0, B is equal to 8, it works. Or put A is equal to 9 and B is equal to 8, it works. It works for 3 ordered pairs of values. Okay, did it make sense to you? Understood? Understood? These are a little bit of exam questions, simple exam questions, what we are doing on the divisibility rule, and a thorough revision from your high school. Making sense, my friends? Is it making sense? I'm hoping it's not too deep. It's making some sense to all of you. Yeah. All right. All right, cool. All right, now let's kind of stop it out here. Let me do some quick announcements. So if you are looking at the structured courses, certainly if you are looking at the structured courses, So there are some structured courses starting today, that is on 22nd December. There are certain structured courses planned to start today, and one of them is called as a Sunrises batch. This is for the SNAP. Alright, if you are a CAT 21 student and if you are looking at the SNAP and ZAT kind of it, that's when it makes sense out here, right? Yeah. Or so if you are also so looking at the CAT 22, there is a batch which recently started. They might not have done too many classes, maybe 2-3 classes they might have done. You can consider these batches as well. So what happens in these batches is you get a very structured learning, in the sense if you go to this particular batch, droppers batch, and find out the details, there the educators will tell as to what they are planning to cover, how they are planning to cover. Are they looking at the foundation level? Are they looking at the intermediate level? Are they looking at the advanced level? Or the batch is going to cover all three of them? Likewise, you get the specific inputs. There will be a small video. Watch that particular video before you take up that particular batch, right? Take up that particular batch. But how do you get access to these particular batches? You may have to get the subscription, right? Through subscription. Now these are the subscription charges for 6 months, 12 months, 18 months and 26 months based on what is the kind of duration that you are kind of looking for. Now on these nominal prices, you will also get 10% discount. You use any of the educator code using my code, which is Belvi 100. So Belvi 100 doesn't mean that you will get 100% discount. You still get 10% discount on these listed prices, which means this might end up becoming 15,000 rupees, etc. Right? This might end up becoming somewhere about 20,000 rupees, etc. Right? Yeah. But my preference being, since you are looking at a structure, if you are looking at the proper preparation, go for Iconic subscription for a simple reason that if you take 6 months Iconic subscriptions, you will get 25 one-to-one counselings, right? In the sense you can schedule the counseling 25, well, 6 months is nothing but about 25 weeks. One sitting with the mentor of your choice, right? You can sit with the mentor of your choice for a one-to-one counseling, which is a huge advantage. In the sense you can always say that, hey, so this week this is the agenda. The agenda is also decided by you. You can decide, okay, this week I want to sit with the mentor and discuss about how I want to carry out my preparation for the month of January. This is my background. This is based on this particular background, how my study plan should look like. Am I good in verbal? Am I good in quant? Which areas I'm struggling? So which material I should follow? How do I go about it? Every one of you is unique. So therefore, in these sittings, in these 25 sittings, week on week, you can kind of understand that how you want to go about it, right? If it is a 12-month subscription, you will get 50 sittings, right? 50 one-to-one sittings you can do. You can have an agenda. If the tests are coming closer, you can say that, hey, what should be your test strategy? What should be your tests plan? Right? So closer to the interviews, when the interviews are coming, you can validate. Already you can validate your answers. So this is my profile. Based on this profile, what can be the questions? Will this answer as a strength be viable? So like this, all right, in these 25 sittings, you can decide what is the agenda, crisp agenda, and then discuss about that, right? So that's what you mean by Iconic subscription. In addition to all the structured courses, you also get access to the mentor about 25 sittings, 50 sittings, right here, 100 sittings, etc. Right, which is definitely going to be a big push into your career. Right, good. So not only that, all right, now along you can discuss anything. You can discuss your doubts, you can discuss your concepts, whatever that you want to discuss in those particular sittings, all right, that's your choice. But now there is a limited period offer. Just now I said that in a 6 months you get 25 sittings, not 25, you get 35 sittings. That is 40% extra sittings. 35 sittings if you buy a 6 months for subscription. I said that if it is an annual subscription, 50 sittings, but not 50, it is 70, 20 extra sittings, right? Yeah, that's how you're kind of getting it out here, right? You are getting more one-to-one sittings if you are buying the subscription during the limited period offer. Also, if you are buying the plus subscriptions, you have some offers here. If you buy 12-month subscriptions, you have 2 months free. You have 24-month subscription, you have 2 months free. If you are appearing for CAT 22 or CAT 23, these subscriptions might suit you, right? And offer ends today. All right, sadly, today is the last day to end this particular offer. Yeah, that's pretty much about what I wanted to convey in today's lecture. I will sure see you tomorrow at 4 p.m. My lectures will be at around 4 p.m. Join me at 4 p.m. for CAT Mojos. That's what we titled it as. Join me at 4 p.m. So every day, so we will discuss the foundation, then we will go to intermediate, then we will go to advanced, right? That's how we go about it. Press the bell icon and then you can subscribe so that whenever I start the lecture, you will kind of get a notification. If you have liked the presentation, be it online or offline, whatever that you have heard, if you like the presentation, you can always encourage me by putting the like button. And how can you reach out to me? So this is how you can reach me. You can use one of these Telegram channels and you can reach me there for short discussions, or it could be for your doubts, etc. You can reach there, and you guys, there are many other students as well. You guys can help each other on this particular Telegram channel. Yeah, that's pretty much about it from me today. I will see you guys tomorrow at 4 p.m. with the continuation of this particular lecture. Bye till then, and stay blessed. God bless you. God bless you. God bless you. Yeah, bye guys. Bye.